Okay, so this is now the Year 7 reactions knowledge test. Right, it's all to do with the chemical reactions, right, that then obviously you need to know. Now, list 5 signs of a chemical reaction, right? What they are is you can get a colour change, you can get a temperature change, you can get sound, you can get fizzing, and you can also get a new product formed. Okay, so chemical, a bit like me really, right? If I get dead angry, I'll go red in the face, I'll go hot, right? I'll make lots of sound, I'll fizz and steam will come out of my ears, and then I'm not quite sure what the new product formed is, right? But that's kind of the signs of a chemical reaction. Describe the difference between a chemical reaction and a physical change. So chemical and physical. Okay, so we've got a chemical change and a physical change, right? So a chemical change is there will be a new product and it is irreversible. And a physical change, it is no new products and it is reversible. Okay, a good one of this one is melt ice. Okay, so there's no new product, but then it is reversible. It's like a physical change between the two. Number 3, what 3 things make up the fire triangle? Okay, fuel, oxygen, and heat. Okay, I often think that draw the triangle. Fuel, oxygen, heat. So comparing complete and incomplete combustion. So complete combustion, you get water and CO2 formed. Incomplete combustion, you get water, you get CO2, but also you get carbon monoxide. So that's kind of the difference between them. Complete combustion, you get a nice clean flame. Incomplete combustion, you get a dirty, sooty flame. In this one, the fuel is oxidized completely. And this one, it is not fully oxidized. Best example of that, this is Bunsen flame, blue flame. Bunsen flame, orange flame. So in blue flame, water and carbon dioxide is formed, the flame is nice and clean and it's fully oxidized. The orange flame, you're actually getting carbon monoxide made, it's dirty, it's sooty, and it's not fully oxidized. What is the law of conservation of mass? It is where matter cannot be created or destroyed. Question number 6. Describe 3 investigations that carried out to prove the conservation. Right, so I'm just going to talk about the actual practicals itself. So burn, magnesium and oxygen, calcium, carbonate and hydrochloric acid, and lead nitrate plus potassium nitrate. Question number 7. Describe what happens when you thermally decompose calcium carbonate. Right, so what you have is you have calcium carbonate, you heat it, because that is then thermally decomposing it, and what you make is you make calcium oxide plus CO2, right, which is the gas that comes off at the end. Question number 8. Compare exothermic and endothermic. Give 2 examples of each type of reaction. Right, so heat transferred to the surroundings. Endothermic, heat, put 2 there, heat transferred from the surroundings. Second one is an exothermic reaction will be a rise in temperature. An endothermic reaction, there is a fall in temperature. Products have less energy than reactants because energy has been lost. Products have more energy than reactants, okay, because the products is taking energy in. Good examples, let's change the colour again, let's go for a bit of green, right, is burn ethanol, in fact burning anything really, and respiration. Okay, so respiration gives out energy. Melting ice, and another good one is photosynthesis. Is a good endothermic reaction. Draw and label an energy level diagram for an exothermic reaction. Okay, line, you obviously use a ruler, energy, line up and down like that. Okay, that is a reactant, that is the product. And what you have is that line there is the activation energy. Okay, activation energy, that's terrible. Right, so reactant, right, you then put in activation energy, right, energy is then lost, making the product at the end. Right, so that there is the amount of energy released. Okay, draw an energy, label an energy diagram for, I think that must be an endothermic. Let's change that to endothermic, could have just done exothermic. There's my line, there's my line, there's my energy. Right, and this time what happens, it goes along like that, does a little bump, then it goes like that. Okay, so this, let's change the colour to reactants. And these are then the products. And the activation energy is that. So that's the amount of energy required to actually make it happen. All right. This distance here is the energy in. Keywords, right? The chemical formula represented by the reactants and the products. This equation shows how many atoms are rearranged and gives the relative amount. That's a balanced symbol equation. A fuel from remains of animals and plants, fossil fuel, a material that burns to transfer useful energy, fuel, a chemical reaction in which substances react with oxygen to form oxides is oxidation, and the way of representing a chemical reaction simply, right, is a word equation. Now, what you do now is you do the test. Okay, you do it, you've written it all down on your piece of paper, then you go to the other video, right, and the other video then goes through each individual blank question, and what you then do is you've then got to write down on a piece of paper, then check yourself, red pen it, check yourself, right? This is all about checking to make sure you remember the facts.